The worst mistake most people make when their car's heater stops blowing warm air is rushing straight to a mechanic, often leading to unnecessary part replacements and sky-high repair costs that can easily hit $1,500 or more. Instead, try this simple, low-cost trick that can dramatically boost your heater's output, making it feel twice as powerful. The key item you'll need is super affordable. Under $6, and I'll reveal it toward the end. Plus, stick around for a bonus tip at the close that helps avoid up to 40% of common engine breakdowns. Let's dive straight into the step-by-step fixes that solve most no-heat issues without touching expensive tools or shops. Number 1, inspect the thermostat first. A faulty thermostat is behind a huge chunk of heater failures. Experts often point to it as one of the top culprits, especially in cars older than 8 years. If it's stuck open, coolant flows constantly without the engine reaching proper operating temperature, so the air from your vents stays cold no matter what. Watch for that ignored check engine light, a common code like PA128 signals. The coolant temp is staying too low because the thermostat isn't closing properly. The ECU might not always flag it right away, so do a hands-on check. After shutting off a warmed-up engine, carefully feel the upper radiator hose. If it's still cool while the engine is warm, the thermostat is likely stuck open and needs replacement. This cheap part, often under $20, can restore full heat fast. Number 2. Always verify your coolant level and condition. Surprisingly, coolant isn't just for preventing overheating, it's essential for producing cabin heat too. Yet most drivers rarely inspect it until something goes wrong, with surveys and mechanic reports showing only a small fraction check it routinely. Low coolant lets air pockets form, especially in the heater core, one of the highest points in the system, blocking hot fluid from circulating. No hot coolant means no heat, even with the fan blasting. When the engine is completely cool, check both the radiator, carefully remove the cap, and the overflow reservoir. The level should sit between min and max marks, never bone dry or overflowing. Top off with the right coolant mix if needed, but avoid overfilling, as excess can create pressure issues, leading to leaks, overheating, or even electrical glitches. A quick top-up is often all it takes to get blazing hot air again. Number 3. Confirm the engine reaches proper operating temperature. Older vehicles especially need time to warm up fully before the heater works well. Start the car, take it for a short drive, and monitor the temperature gauge closely. The needle should settle right in the middle once everything's warmed up, usually after 10-15 minutes of driving. If it stays pinned low even after that, you're dealing with a circulation issue like the thermostat we mentioned earlier. If it climbs too high, that's another cooling system red flag. Only when the engine hits optimal temp will the coolant be hot enough to transfer warmth through the heater core. Number 4. Optimize your climate control settings properly. Many drivers overlook basic controls, even with simple knobs. Fancy touchscreen systems make it worse. Skip auto mode for now. Crank the temperature selector fully to the hottest setting, all the way red. Start the fan on low speed, then gradually increase it as the engine warms. Crucially, hit the recirculation button to pull in already warmed cabin air, instead of constantly heating icy outside air. In freezing conditions, this makes a massive difference in how quickly and intensely the heat builds. Just avoid recirculation if your windows are fogging up, as it can trap moisture longer. Number 5. Test the blend door actuator for proper operation. This small motor, or sometimes a heater control valve in older models, directs airflow between the hot heater core and cold outside air. When faulty, you might get only cold blasts, sudden swings between hot and cold, or no response to temp changes. A telltale sign is inconsistent temps, or the system flipping on its own. Quick DIY check. With the engine running, turn the temp knob to full cold, wait a moment, then swing it to full hot. Listen closely near the dash. You should hear a distinct clicking or knocking sound as the actuator moves the door. If it's silent, grinding, or the temp doesn't change, the actuator may need replacement. Usually $150 part, DIY friendly in many cars. Number 6. Evaluate the blower motor and resistor. If air barely moves or speeds are erratic, the blower system could be failing. This component pushes air across the heater core. Test it on cold mode first for safety. Start at the lowest fan setting and ramp up to high. Speeds should increase smoothly. If they stay stuck, jump randomly, or no air comes out at all, suspect the resistor, cheap common failure, or the motor itself. First, check the fuse with a tester or multimeter. A blown one is an easy fix. If the fuse is good, replacement parts run around $100 for a decent kit. Always choose quality components to avoid repeat failures that could harm the engine. If all these checks pass and heat is still weak, the issue might be a clogged heater core, air in the system, or something rarer. But these steps fix the vast majority of cases without big bills. Number 7. Examine the heater core closely. If you've made it through the earlier checks without fixing the weak or non-existent heat, the heater core itself is often the hidden culprit. This compact heat exchanger, basically a mini radiator tucked behind the dashboard, can gradually clog up with debris, turning what should be hot air into barely warm puffs. Locate the 2 heater hoses attached to the firewall, those thick black lines running from the engine bay into the cabin. With the engine fully warmed up and then safely cooled down a bit, carefully feel both hoses. One should be noticeably hotter than the other if flow is restricted. If both feel lukewarm or one stays cold, blockage is likely. Over time, degraded coolant allows rust particles, scale, and sediment to accumulate in the narrow passages, choking off circulation. Mechanics frequently push for a full heater core replacement, which can run $800 to well over $2,000, depending on the vehicle. Especially pricey on luxury brands where dashboard disassembly adds labor hours. Others suggest a standard coolant flush, but that rarely clears deep sludge in the core and often provides only temporary relief before the problem returns. Instead, consider a targeted CLR-based flush using calcium, lime, and rust remover, a popular DIY approach that succeeds in clearing blockages for many owners, often restoring strong heat without major expense. This method works well on scale and rust buildup, though results vary and it's not foolproof. Always prioritize safety to avoid damaging components. How to perform a safe heater core flush yourself. Doing this at home typically costs under $30 or $50 in supplies versus $150+ at a shop. Gather these items: CLR cleaner, a garden hose with low pressure control, protective gloves and eye goggles, pliers or hose clamp tool, a drain pan or bucket, compressed air source, optional but helpful, a funnel, and fresh coolant for refilling afterward. Step 1. Rule out a leaking heater core first. Flushing a leaking core can worsen damage, potentially soaking your carpets, dashboard, or electronics, and leading to expensive interior repairs. Check inside the cabin for a sweet antifreeze smell, foggy windows that won't clear, or wet spots, drips, on the passenger side floor mat. Also inspect under the car near the AC condensate drain for pink-green coolant mixed with water, not just clear condensation. For certainty, use a cooling system pressure tester, borrow one or ask a shop. Many do basic tests free or cheap. If there's any leak indication, skip flushing and opt for replacement instead. Stop leak additives won't reliably seal heater cores and can cause further clogs. Step 2. Disconnect the heater hoses safely. Wait until the engine is stone cold to avoid burns or pressurized spray. Position a large catch pan below to collect old coolant. It's toxic. Handle and dispose responsibly at a recycling center. Use your tool to loosen the clamps on both inlet and outlet hoses at the firewall, then gently twist and pull them free. Expect some residual fluid to drain out. Step 3. Clear out remaining coolant. Use compressed air, keep it under 20 to 30 psi to avoid damaging delicate fins, blown into one hose opening to push out leftover coolant from the core. Switch sides and repeat. This preps the core and reduces mess during the cleaning phase. Step 4. Introduce the CLR cleaner. Wear full protective gear. CLR is a strong descalaire and can irritate skin or eyes. Attach a short hose or use a funnel directly on one heater core nipple. Pour in undiluted CLR until it starts overflowing from the opposite side, ensuring the core fills completely. Let it soak thoroughly, aim for 45 to 60 minutes. Some extend to an hour or more for stubborn buildup, but don't exceed excessively to minimize any risk to metals. Step 5. Flush out the loosened debris. Connect your garden hose, set to low flow, about 10-20 psi max, just a partial turn on the tap, to one side and run water through until it runs clear on the exit. Watch for dark, rusty gunk coming out. This confirms the clog is breaking up. Repeat the CLR soak and flush cycle if needed. Shorter soak this time, like 30 minutes, until water exits clean from both directions. Step 6. Reconnect everything securely. Reattach the hoses firmly, tighten clamps properly, don't over-tighten and crush them, and ensure no leaks at connections. Step 7. Refill and bleed the cooling system properly. This is critical. Skipping it invites air pockets that cause hot spots, overheating, warped heads, or full engine failure, repairs easily hitting thousands. Use the manufacturer-recommended coolant type. Wrong mix can lead to gasket failure or corrosion. Remove the radiator cap, engine cold, install a spill-proof funnel if possible, cheap kits available, and fill slowly to the top. Start the engine with heat on max and fan low. Watch for bubbles rising as the thermostat opens and air escapes. Top off as level drops. Rev gently if bubbles are slow. Once the temp gauge stabilizes in the normal range and hot air blasts from vents, shut off, remove funnel, cap it, top the reservoir and test drive. Recheck level after cooling to confirm no air remained. Bonus maintenance tip. Routine coolant system flush to prevent repeat issues. Neglected or degraded coolant causes a significant portion of heater core problems by allowing corrosion and deposits to build unchecked. Flush the entire system every 2 to 5 years, or 30,000, 60,000 miles. Check your manual. Some extended life coolants go longer, but most benefit from regular service. Professional flushes cost $150 to $250, but DIY is straightforward and saves money. Step-by-step quick full system flush guide. Drain old coolant via radiator petcock into a pan. Refill with distilled water plus a quality flush chemical, or just distilled for basic rinse. Run engine 10-15 minutes, heater on to circulate through core, monitoring temp. Cool completely, drain again. Open cap Joch reservoir for faster flow. Repeat water rinses until clear. Refill with proper 50-50 coolant, distilled mix, then bleed as described earlier. Test drive and recheck levels. Follow these steps carefully, and your heater should deliver powerful, consistent warmth again, often better than before. Skip the big shop bills and keep your cooling system in top shape to avoid bigger engine headaches down the road. If issues persist after this, it might be time for professional diagnosis, but this tackles most clog-related no-heat complaints effectively.